cooling tower is a chapter coming in the third subject. Actually, it is full a mechanical subject, but it comes in the electrical utilities, energy savings in electrical utilities. It's also an important chapter. So we, for those who are in thermal power stations, it will be very much useful. It will be very much useful. We will see the basic definitions and basic operations, sir. And the calculations and other factors will be seen on the, as usual, on 11th day. The objectives, sir. Up to the fourth or fifth point, you will be seeing, sir. Good. This is the cooling tower, sir. Actually, we have seen this cooling towers from our school days, but we did not know what purpose it was there. Even after entering a thermal power station, which are not having a cooling tower, the concept of cooling tower working.
Sir, our conventional,
is unknown to many of our engineers, sir, especially.
Sir, our
after
cooling tower is different, sir.
Yes, sir.
This is different.
Yes, sir.
Our conventional towers,
yes,
we used to have fan at the
sir,
top.
please.
Okay. Proceed, sir.
Yes, sir. We'll be seeing, sir. We'll be seeing everything, sir. Just a slide, sir. That's all. Actually, the original Basin Bridge power station was having a cooling tower, sir. And Mettur thermal power station is still having a cooling tower. And the 600 megawatt new power station in Mettur station 2, 1/600 megawatt is also having a cooling tower. But in North Chennai, 2 10x3 and 2x600 do not have any cooling towers. The condenser is cooled by once through seawater system. Nowadays, even for seawater power station, once through cooling water is not allowed by Ministry of Environment and Powers. It is mandatory to build a cooling tower. Nowadays, it has become mandatory. That's why in stage 3 and 1/660 ETPS expansion project, 1/800 North Chennai stage 3 projects are having cooling towers. In stage 3, construction has been completed almost. In ETPS expansion, it is still in the initial stage. The project is also not progressing right now. Okay, sir. We have got the basic principle is evaporative cooling. That's all, sir. So one word we can say evaporative cooling. The evaporative cooling, just like a hot water and everything, it is the temperature. The minimum temperature we can reduce is to the wet bulb temperature. Beyond which we cannot, even theoretically, we cannot reduce the temperature. This is the working principle. The small zip file is inside a natural draft cooling tower, sir. There is no fan at all. This is the modern day cooling tower. The primary task of a cooling tower is to reject heat into the atmosphere. What is that major heat, sir? The major heat is the latent heat contained in the steam. It is not the sensible heat, it is the latent heat. That's why we need such enormous quantity of water. The heat reject is very high, but the temperature is very low. That's why we cannot get the heat for useful purposes. In some countries, the heat is being utilized for supplying hot water to homes in the nearby town. But we don't require hot water and all, and we cannot use that. Basically, the condenser outlet temperature will be less than 48 degrees. Am I right, sir? Steam temperature. The exhaust temperature will be less than 50 degrees. The cooling water inlet temperature is in the ambient temperature, and it can take away heat with a rise of temperature at the most 10 degrees centigrade. Okay, sir. So all this data are known to you already, right, sir? Okay, sir.
So it can only suppress 10 degree above ambient, correct, sir? Temperature. It will reduce only to 10 degrees.
No. It is not so, sir. But
Okay.
the available temperature is very low. At the exhaust temperature, the available heat is enormous, but the
Okay.
temperature is very low. That's why we are unable to utilize the heat for any useful purposes.
Okay. Okay.
So the inlet temperature may be in the range of 30 degrees. The outlet will be in the range of 38 degrees centigrade. With a mass flow of 38 degrees centigrade of hot water, what can we do, sir? We can do nothing. Practically do nothing. But NIOT, NIOT, National Institute of Ocean Technology, they tried something in NCTPS 1. It was a pilot project for whole India. They tried to utilize this heat to evaporate the temperature, evaporate the water, and then condense to make desalinated water. They were trying to supply just 100 homes of Vallur camp. Actually, 400 homes, 400 residential houses were in our thermal quarters, but the total capacity was able to supply 100 houses only, but that too was almost a failure. Actually, what they do is they create artificial vacuum by using vacuum pumps, so that in the low vacuum, the water gets evaporated. Normal water can be evaporated. Normal water will be in the range of ambient temperature, but this one will be 8 or 10 degrees more than ambient. So we can, so the energy consumed for creating vacuum, producing a desalinated water will be less than what is required for normal water. But that too was failure actually. Only what is the reason, sir? Because the outlet temperature is very low. That temperature we cannot use for any purposes. But the heat contained is enormous. That's why that much quantity of heat, water is required. since it has become mandatory to build a cooling tower, we are forced to construct a cooling tower. The cooling, what is the difference between a cooling tower and once through system? In once through system, as a thumb rule, if you require 1 lakh meter cube of water in once through system, we will require 10,000, only 10,000 liters of meter cube of water only in cooling towers. Actually, as you may think, it will be circulating and it may not require top of water, but it is not so. It actually consumes nearly 1/10 of the cooling water as used in the once through system. Hot water from heat exchangers, condenser. Actually, in our case, we are seeing condenser. The condenser water is the cooling water after getting the heat from the steam. What is the heat it is getting, sir? It is a phase change heat, sir. Phase change heat, not a sensible heat. It is a phase change heat. That's why it is of very huge quantity. Converting from steam to water requires much of cooling water. That water has to be, that phase change has to occur. Otherwise, thermal cycle will not occur continuously. The water coming out of cooling tower after losing it is sent back to the condenser or heat exchanger. Up to this, it's okay, sir. Right, sir. Am I right? Is it okay for you? Actually, we are getting water from sea. Let us see one example. It is sent to the condenser. In the condenser, the steam is converted into water. The seawater gets heated up to nearly to 8 degree or 10 degrees centigrade, and the hot cooling water is sent back to the sea. Now, we are not sending it back to the sea. We are recycling it into a cooling tower, and we are getting it back at the ambient temperature, theoretically ambient temperature, and once again we are circulating it into the condenser. That's all. What are the types of cooling towers?
Only makeup you are doing, sir. See what
Yes,
you are
sir.
taking.
Yes, sir. Yes, sir. That makeup itself is 10%, sir.
10%. Okay, that will definitely happen. Normal cooling tower itself, you have to make up for certain percentage. Okay.
There are two. One is natural draft, the other one is mechanical or forced draft. We were using mechanical draft up to this last one decade before. We were using mechanical draft only. Nowadays, as per the advice of MOEF, we are using natural draft cooling tower, in which the total energy consumption by the fan is avoided. Huge concrete chimney to introduce air into the hot water. Generally used for large flow of cooling water, that is above 45,000 meter cube per hour. It is happening only in power plants, sir. Nowhere else. The natural draft cooling tower, NDCT, colloquially we call it as NDCT. In the book, anywhere I did not find that word NDCT. NDCT is found in the MOF documents and all. NDCT means natural draft cooling tower. So this is the mechanical draft cooling tower. That is, it is requires an active fan. Actually, see this, sir. The air enters through the louvers, and it's a cross flow, and during crossing this cooling tower, the water flows downwards and it takes away the heat from that water, and theoretically only the hot air goes up. Actually, it doesn't happen. The hot air with water vapor goes up, so that losses are significant. We'll see it. It's a cross flow type, sir. We use large fans to force air through cooling water, circulated water. Water falls downward over fill surfaces. Fills. Fills actually, they separate the water. The huge cooling tower, sir, actually the water is made to fall from around 20 meters or less, I think. Actually, the vast height of that cooling tower is empty. The water is falling from the lowest point up to around, it is around equivalent to a 5-story building, that's all. From that level, water is made to fall. The air is moving upward by the natural mechanism, that is low vacuum is created inside the tower. The air goes from bottom to upward, water falls from top to down. So there will be relative motion from relative movement for the both flow, air and water flow. So the cooling effect becomes more effective. Water falls downward over fill surfaces. Fill self increases the contact time between water and air. This heat transfer between two. Cooling rate depend upon the fan diameter and the speed of operation. We are talking about mechanical draft CT, sir. This is counterflow. What is that counterflow? Hot water is made to fall. The fan is running on the top. The air is coming through the lowers. Air flow in the upward direction, and the water flow from top to bottom. It is perfectly an example of counterflow cooling tower. What is it? Cross flow. Water flow, sorry, the air flows in the cross way. Water is made in the perpendicular direction. So it is called cross flow tower. Sir. This is called cold water basin, sir. The bottommost point is the cold water basin, and the slight depression you can see, it is the sun. These are lowers. These are called fill. This is fan. Theoretically speaking, the upward red arrow should be hot air only, but it is not happening. Hot air with water vapor goes out to the atmosphere, making a water loss. This is concrete structure. Air flow inside. Hyperbolic counterflow, natural draft. Yes. Up to this diagram, we saw mechanical draft cooling tower. Now this is natural draft cooling tower. Yes, sir. You can see the fields, sir. Water is made to falls on the top. This fills separate the waters and making it to fine particles, so that the water gets more contact area with the upcoming air. Fills facilitate heat transfer by maximizing water and air contact. fills can be flash type or film type. Flash means it makes into particle. The film means it makes a continuous film type. In both cases, the contact area is increased. Water falls over successive layers of horizontal splash bars, continuously breaking into small droplets while also wetting the fill surface. Plastic splash fills gives better heat transfer than wood. Fill consists of thin, closely spaced plastic surfaces over which the water spreads, forming a thin film contact with air. I saw in thermocouple, these fills are very thin, and I saw huge quantity of fills in the yard. One of the fills. Actually, the fins were less than 0.5 mm thickness, but actually the scale formed in those fills were of thickness up to 20 mm, sir. I saw. See, all these arrangements are made to make the water divide into droplets. Cold water basin. The cold water basin is located at the bottom of the tower, near the tower, or near the tower. Most of the cases I have seen in bottom only, but in this book they are giving near the tower. I have never seen such a tower where the cold water basin is located adjacent to the tower. In all the cases I have seen, cold water basin is located at the bottom of the tower only. It receives the cold water that flows down through the tower and the fill. The basin usually has a sump or low point for cold water discharge connection. We just saw one depression. No? Yes, sir. This is a cold water basin, sir. Drift eliminators. Drift eliminators are provided to capture water droplets entrapped in the air stream that otherwise would be lost into the atmosphere. When the air is going upward, it captures the water particles and take it away with them to the atmosphere. Then we will be losing huge quantity of water. So we need to have some mechanical arrangements so that while going through the drift eliminators, the air gets condensed and the water drops down due to gravity, and the air leaves the drift eliminators with reduced quantity of water in the air. What are the advantages? First major advantage is saving of water. Second thing, the electrical pots and piping system in proper condition by preventing corrosion. Actually, in Thermocouple power station, it's a huge problem. So they're adding sulfuric acid with the cooling water to control the algae growth and all. But due to this water carryover, it corrodes the nearby iron structures in the surrounding. I've seen many iron structures got damaged in the even handrails and everything. The staircases, everything got damaged in Thermocouple. Short circuits which when occur due to damaged electrical ports can be prevented. Any terminal box and all will experience a short circuit if the door is opened because of this moisture in the surrounding air due to cooling tower. Drift eliminators ensure that the emission of hazardous chemicals into environment is significantly reduced. Actually, we saw this, sir, in Tuticorin. The NPTL has huge two cooling towers. In the adjacent to the cooling towers, we have got the approach road to the cooling thermal power plants, and they planted 6 years back many tree saplings, and they grew well up to 6 feet. Actually, the cooling tower was then constructed after the growth of those trees, saplings. After the construction of cooling tower and started functioning, the plant started functioning, the NTPL power plant started functioning, the trees got damaged. Almost all the trees, sir. I more in the single road, more than only because of this splash from the cooling tower. Because they are using chemical. Everywhere the chemical is used to contain the algae growth and all. To reduce this condition, drift eliminators are used. Water conservation at large scale is possible due to drift eliminators. All these things are in theory only, sir. In practical, it is not happening. So I don't know one problem or practical status study. There is no need for additional water treatment. Water is conserved, then water treatment is also reduced. That's all. Lifespan of cooling tower is also increased. Significantly reduces energy consumption. So drift eliminators, what are the major points of drift eliminators? We have to keep in mind. We may be asked to list out the points. One such drift eliminator, sir. We saw fills previously. This one is different. Fills are different from drift eliminators. Fills used to separate the water particles or divide the water particles or to make a thin film, to make more contact of water with the air. That is the purpose of drift eliminators. But this one is previous one is fills. This is the drift eliminator. What's the purpose of drift eliminator? To reduce the water escaping into atmosphere. Right, sir? See. Mechanically, it is made to follow your path and the water droplets coming down due to gravity by condensation. That's all. This is the purpose of drift eliminators. So you get the difference from between fill and drift eliminators, sir? Sir, actually, what? See the quantity of water vapor going out of a cooling tower. Sorry, I accidentally pressed the quit button. The air entry point. This is the point of entry for entering a tower. Actually, for in this place, there should not be any buildings or even trees which would otherwise obstruct the air flow into the bottom of the tower. Cross flow design. All these things are depending upon the types of tower. Structure and all, we have seen this already. Water lowers. The lowers are generally used in cross flow type The lowers is usually, sir, found only in mechanical type, sir. That is conventional type. It is not used in the natural draft cooling tower. The purpose of lowers is to equalize airflow into the fill and retain the water within the tower. This is called induced draft double flow. Double flow, cross flow tower. Cross flow means air is flowing in the direction opposite to the waterfall. And induced draft means kept in the top, not at nozzles. Nozzles provide water sprays to wet the fill. For proper wetting also, the uniform water distribution at the top of fill is essential. Previously, fixed nozzles were used. Nowadays, rotating type structure is also used. Fixed or mounted in rotating assembly. See the nozzles, sir. The bottom structure, you can see the fills. Just have a closer look. These are all nozzles, which is of natural draft CT. The water coming out there. Sir, actually, in a NDCT natural draft cooling tower, the energy consumption is nil. We may presume like that. Actually, there are no fans, so there will be no electricity consumption. But the basic principle of airflow into the cooling tower is made by the water nozzles. The water nozzles actually spray the water with high velocity. Because of that high velocity, vacuum is created. This vacuum sucks the air from the surrounding of the cooling tower through the bottom opening, so that airflow is maintained. Because of making the water ejection at a high velocity, we need to increase the power of the circulating water pump. Otherwise, the circulating water pump will be of a lesser capacity only. But this is very marginal compared to the fan capacity. This is only marginal, but there will be an increase in energy consumption. Okay, sir. Sir, any doubts, sir? This is an important point, sir. The low pressure sucks the ambient cold air into the tower. The kinetic energy of water, the energy imported by the circulating water pump. Since fans are not used in NDCT, the energy is saved, but a marginal increase in energy consumption for pumps. Even in mechanical draft, that is forced draft cooling towers, there will be water pumps. Here also water pumps will be there. But this one, natural draft cooling tower, we'll have to.
அப்படியா சாப்பிட ஆப்ஷன் இல்லையா
சாப்பிட்டு ஒரு பார்த்தாச்சா இட்லி தோசையில ஒன்று
In NDCT, there will be slow noise and there will be no vibration at all, sir. The velocity of water in the conventional system, high efficiency drift illuminators together will reduce water loss to a tune of 0.001%. These are all the features of natural draft city. Low maintenance cost because there is no rotating part. for this all the basic definitions, sir. What is the range? Range is the difference between cooling water inlet temperature and outlet temperature. Range. Sir, please keep in mind all these things are essentially required. What is range? What is approach? What is COC? And all these things we have to be thorough with them. Approach. What is that approach? This is the difference between cooling water outlet temperature and ambient wet bulb temperature. Actually, this will be in the order of 6 or 7 degrees centigrade, sir. More than 4 degrees centigrade. If you want to reduce it further, we need to design the cooling tower to an enormous size. But that will be costlier and a huge investment we may be required. So we limit to a certain degree of approach. Cooling tower effectiveness. Cooling tower effectiveness is the ratio of range bar range plus approach. What is that range? Range we saw, it is the difference between cooling water inlet temperature, that is cooling water, cooling tower, sorry, cooling water, not cooling water, cooling tower inlet temperature, that will be hot, that is coming out from the condenser, which is made to fall over the fill. That is cooling water inlet temperature. What is the outlet temperature? It is the cooling water outlet temperature that is in the bottom of the cooling tower. That is cooling water basin, we call it. Approach is the difference between cooling water outlet temperature and the wet bulb temperature. In ideal case, we can cool the temperature, we can cool the cooling water or hot water to ambient wet bulb temperature. That is theoretical. See this formula as a range bar range plus approach. When this approach becomes lesser and lesser, what will happen? Both numerator and denominator will approach
1.
Yes.
Range by range is equal to 1.
Yes, sir. Yes, you're right. What is cooling capacity? Cooling capacity is heat rejected in kilocalorie per hour as given in the mass flow rate of water, specific heat and temperature difference. Just keep this in mind, sir. This is hot water temperature. That is the temperature coming out of condenser that we have to cool. Right, sir? That may be in the range of 38 degree to 40 degrees centigrade. On the cold water temperature, it will be, if it is 38, this will be in the range of 30 degree, or ambient wet bulb temperature is recorded in the room with a wet wick in the tip of the thermometer. Evaporation loss. The quantity of evaporated water evaporated for cooling duty.
Sir, one doubt, sir. Note.
Yes, sir. Yes, sir.
Sir, what is the difference between wet bulb temperature and dry bulb temperature? Sir.
Wet bulb temperature வந்து சார் நம்ம சாதாரண தெர்மோமீட்டர்ல ரூம் டெம்பரேச்சர்ல வந்து ஒரு ரூம் டெம்பரேச்சர் ஒரு 27 டிகிரி இருக்குன்னு வச்சுக்கோங்க சார். அதே தெர்மோமீட்டர்ல வந்து முனையில ஒரு பல்பு கட்டி வச்சிருப்பாங்க. அதுல வந்து அந்த துணி மாதிரி சுத்தி வச்சிருப்பாங்க, பஞ்சு மாதிரி. அதில் நம்ம என்ன பண்ணோம், பீரியாடிக்கலா அதை தண்ணி விட்டு நினைச்சு வைக்கணும் சார். அது நம்ம யூசிபில கூட இருக்கும், சில இடத்துல நினைச்சு வைக்கணும். அது என்ன ஒன்று கேட்டீங்கன்னா, ஆம்பியன்ட் வந்து 27 இருந்ததுன்னா இது ஃபர்தரா குறைக்கும். இது ஃபர்தரா குறைக்கும்னா என்னத்தை குறைக்கும்னு கேட்டீங்கன்னா, அந்த வாட்டர்ல வந்து இருக்கிற ஹீட்டை எடுத்துக்கிட்டு மேல இருக்கிற விக்ல இருக்கிற வாட்டரை வந்து எவாபரேட் ஆகும். எவாபரேட் ஆச்சுனாக்கா அப்ப என்ன ஆகும், இன்னும் ஃபர்தரா அந்த டெம்பரேச்சர் குறையும். சரி, இந்த வாட்டரை வந்து இதே மாதிரி எவாபரேட் ஆகிட்டே இருக்குமா, எவ்வளவு ஊத்தினாலும் நல்லா குறையுமா, ஐஸ் மாதிரி குறைஞ்சிருமா அப்படின்னு கேட்டா ஆகாது. ஏன்னு கேட்டீங்கன்னா, இட் டிபெண்ட்ஸ் அப்பான் தி ஹியூமிடிட்டி ஆஃப் தி ஆம்பியன்ட் ஏர். ஹியூமிடிட்டி ஒரு ஸ்டேஜுக்கு போயிடுச்சுன்னா, சர்டன் ஸ்டேஜுக்கு போன பிறகு இது ஃபர்தரா எவாபரேட் ஆகாது, அது சேச்சுரேஷன் வந்துடும். அப்போ வந்து அந்த டெம்பரேச்சருக்கு மேல நம்மளால குறைக்க முடியாது. ஃபார் எக்ஸாம்பிள், இப்போ பானை தண்ணி எவ்வளவு கூலா இருக்கு, அதுக்கு மேல நம்ம இன்னும் எவ்வளவு பெரிய பானை வச்சாலும் 10 பானை வச்சாலும் 100 பானை வச்சாலும் அந்த டெம்பரேச்சர் குறைக்க முடியாது. அதுக்கு மேல ஃபர்தரா குறைக்கணும்னா எவாபரேட்டிவ் கூலிங்னால முடியாது. எவாபரேட்டிவ் கூலிங்க்கு இந்த லிமிடேஷன் இருக்கு. அது எவ்வளவு குறைக்க முடியும்னா அதான் வெட் பல்ப் டெம்பரேச்சர். அது கீழே குறைக்க முடியாது. கீழே போனோம்னாக்கா இந்த சிஸ்டமே முடியாது. அப்போ நம்ம கன்வென்ஷனலா ஃபோர்சிபிள் கூலிங் ரெஃப்ரிஜரேட்டர் அந்த மாதிரி சிஸ்டத்துக்கு நம்ம போய் ஆகணும். ஓகே சார்.
ஓகே சார். ட்ரை பல்ப்?
ட்ரை பல்ப் நார்மலா வர ரூம் டெம்பரேச்சர் சார்.
ஓகே சார். ஓகே சார். ஓகே சார். தேங்க்யூ சார்.
Quantity of water evaporated for cooling duty. For every, this is 1 million, sir. That means 10 lakhs kilocalorie heat rejected. 1 million, sir, 1 million. Evaporation is in the range of 1.8 meter cube. It is a thumb rule. Actually, it has been calculated in various cycles. It is called evaporation loss. For every 1 lakh kilocalorie of heat rejected, the evaporation quantity works out to 1.8 meter cube. There is an empirical equation to calculate this, sir. Evaporation loss in meter cube per hour is equal to 0.00085 into 1.8 into circulation rate in meter cube per hour multiplied by T2 minus T1. Actually, there are very few problems only. I'll search for problems in the examination and present in the next class, sir. Just keep it in mind. COC. It is the main factor for COC.
Sir, one more doubt, sir.
Yes, sir.
How to calculate this circulated septation? How many septation it has come like that?
Pump capacity, sir. That's all. Pump capacity.
Oh.
What we are pumping, it will be in the meter cube per hour only. Cooling water pump. That's all.
Okay.
COC is the rate of ratio of dissolved solids in circulating water to the dissolved waters. Sorry. Not complete the sentence. Dissolve the water to the dissolved solids in the makeup water. Fresh water. Okay, sir. Makeup water is in case of Metor, it is Kaveri water. In case of the new upcoming power plants, it is a fresh sea water. Actually, by circulation, frequent circulation and cooling, after evaporation, the water gets denser more. The ppm will become more. Right, sir? In the cooling water, the circulating cooling water. So we have to add water for making it reduce the dissolved solids in the circulating cooling water. So COC is a main factor for making up. Because of this, we are blowing it down, and there will be blow down loss. Blow down losses depend upon COC and the evaporation loss. COC increases, we have to blow down. Evaporation losses, we have to make up. Blow down is equal to evaporation loss.
Blow down process is letting out some amount of water, sir.
Yes, sir. Yes, sir. We are doing it, sir.
Okay.
One more term, liquid bar gas ratio. L bar G ratio of a cooling tower is the ratio between the water and air mass flow rates. They are calculating in an indirect way, sir. You asked about that circulating water and all. It can be directly inferred from the flow of the motors, but this one, they've got different formula. Against design values, seasonal variations require adjustments of tuning of water and air flow rates to get best cooling tower effectiveness through measures like water box, loading changes, blade angle. Just there is a L bar G is L bar G, they are finding out by the formula heat removed from the water is equal to heat absorbed by the surrounding air. It is purely thermodynamics. And this is the formula. L bar G is equal to enthalpy difference divided by temperature difference. Simple formula only. L means the liquid flow. G is the gas mass flow. We cannot measure it directly. So L bar G ratio is the enthalpy of air-water mixture at the exhaust wet bulb temperature. H1 is the inlet wet bulb temperature. T1, T2 or hot water and cold water. That's all. It's a formula, sir. Factors affecting capacity, the range. Range is determined entirely by the heat load, sir. That is inlet and outlet temperature depends upon the heat load. That is what the heat what is the heat rejected in the condenser determines the range. And the water circulation rate and on the cooling water inlet temperature. Range in degrees centigrade is equal to another formula. Heat load in kilocalorie per hour divided by water circulation rate in liters per hour. We'll be doing some problems, sir. We'll get an idea then. Range is a function of heat load and flow, as already we have seen it. Cooling towers are usually specified to cool a certain flow rate from one temperature to another temperature. Supposing if there is a cooling tower, what is the rating of a cooling tower? How can we say someone has designed a cooling tower? How will they define it? By capacity. Example, it's a cooling tower capacity defined as it will cool 4,540 cube per hour and from 48.9 degrees centigrade to 32.2 degrees centigrade at a wet bulb temperature of 26.7. We can see the rate of the cooling rating of that cooling tower. We can see what
TR is in
we can see, sir. 48.9 minus 32.2 is the range, sir. Yes, sir. It's the range, and 32.2 minus 26.7 is the wet bulb temperature. Approach.
Yeah.
Range and approach. They are giving range and approach. And the capacity of water flow. In this case, 32.2 minus 26.7 is 5.5 degrees centigrade. That is approach. Sir, the size and cost of cooling tower is directly proportional to the heat load, sir. What it must be is size and cost of cooling tower. For 8 to 10 megawatt, the size will be something, and for 800 megawatt, it will be huge.
we call it as
Yes, sir.
TR.
Sorry, sir.
TR. We used to call cooling tower capacity as TR, no?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Low operating temperature is preferable to increase process efficiency. It is desirable, sir, but it is not in our hand. If the calculated load is high, oversize and more costly equipment will be required. The calculation of heat load is a big process. That is not with us, that is with the design engineers. It's a typical heat load calculation, sir. Kilocalorie per kilowatt per hour. In bulb temperature is a controlling factor from the aspect of minimum cold water temperature to which water can be cooled by evaporative method. This is the doubt someone has asked in sir. Initial selection of towers with respect to design. Wet bulb temperature must be made on the basis of condition existing on the tower site. Tower site conditions has also has to be considered for designing a tower, sir. Designing the system, entire system. The ambient wet bulb temperature is the temperature which generally exists in the cooling tower area, ambient wet bulb temperature, whereas the inlet wet bulb temperature is the temperature of the air entering into the tower. The air entering into the tower is not the air in the surrounding area, sir. It is coming from area other than the cooling tower. It is being drawn in by the low pressure created inside the tower. It is very important to have the cold water temperature low enough to exchange the heat or to condense vapors at the optimum temperature level. If the cooling water temperature is low, everything will be fine. Yes, all we know already. So you can see this table. Cold water temperature. And the cold water temperature is low. The flow required is very low. When the temperature rises, the flow required becomes high. Approach is also getting high. Hot water, you can have a view, sir, later. I think on the day also I did not share the PPT. Today I'll do it, sir. Sorry. We'll see the energy saving opportunities and close the section, sir. First one is the manufacturer's recommendations. Recommended clearances around the cooling towers. There should not be trees or structures or buildings in the surroundings, as they may interfere the air intake. Optimize the cooling tower fan angle. This are all design parameters. Correct the excessive uneven blade tip clearance for poor fan balance has to be done. Counterflow cooling towers. Replace old spray nozzles with the new square spray ABS, practically non-clogging nozzles. All these types of just have it in mind, sir. I don't know practically what is ABS non-clogging nozzles. I don't have any idea. Replace the splash bars with self-execution PVC cellular film is effective than the splash bars, sir. That is being told everywhere in the book. Film is effective than the conventional type. New nozzles to obtain uniform water pattern. Periodically clean plugged cooling tower distribution nozzles. Balance flow of cooling tower hot water basins. Cover hot water. Sorry, in the hot water basin has to be covered, sir. It should not be open to sun. Otherwise, there will be algae growth, which will contribute for fouling. Optimize blow down rate as per COS limit. If you blow down frequently, energy will be lost, water will be lost. So for optimum COS limit, we will be doing the blow down. Replace the drift eliminators with that PVC cellular units. Restrict and this point is also I am not aware, sir. Just have it in mind. Otherwise, next time I will search for it and explain it. Restrict flows through large loads to design values. Segregate high heat loads like furnaces, air compressors, DG sets, and isolate towers. Yes. We have to keep within the rating of the cooling tower. That's all. I think we have come to the end. I could not add some more slides, sir, but definitely with complete it in the 11th day, sir. I'll solve some more problems also. Okay, sir. I think we can conclude here. Was it useful?
One, sir, in a slide, 1 degree rise or something, something. The last slide, last line.
Oh. Yes.
Just now you showed
Yes,
me
yes,
last.
sir. Yes, sir. Yes, sir. 1 degree drop in cooling water temperature can
Yeah.
give a heat rate saving of 5 kilocalorie per kilowatt hour in a thermal power plant.
Oh,
That is in air conditioning system and also 1
Yeah.
degree cooling water temperature increase may increase AC compressor kilowatt by 2.7%.
oh,
Yes, sir. That's why they are advising to remove any obstacles from the outdoor unit. That is very much required. We have only air cooled compressors, whereas in for centralized AC and all, it will be water cooling. So temperature has to be kept low. The temperature has to be controlled by the cooling tower only. That cooling tower will be of smaller size now for air conditioning and all. This is the point that they are telling, sir. Yeah, 1 degree cooling water temperature increase may increase AC compressor kilowatt by 2.7%. Okay, sir. Sir, can we conclude, sir? Is there anything else to discuss? Am I audible or not?
No, sir.
What else, sir? Is there anything you can share with me?
நல்லா இருந்துச்சுங்க சார். வேற எதுவும் இல்லைங்க சார். நாளைக்கு கிளாஸ் யாருங்க சார்?
நாளைக்கு கிளாஸா பாலா? நாளைக்கு பாக்குறேன் நானு யாருன்னு சொல்லிட்டு நான் எங்க எஸ்சி தான் பார்க்கலாம்னு இன்னைக்கு போன அவர் கிளாஸ் எடுக்கிறதுக்கு எனர்ஜி எஃபிஷியன்ட் மோட்டருக்கு.
சரிங்க
அவர்
சார்.
இன்னைக்கு கிடைக்கல. அவர் ரொம்ப பிஸியாவே இருக்காரு. அவர் கிடைச்சானா அவர் வச்சு ஒரு எனர்ஜி எஃபிஷியன்ட் மோட்டார்ஸ் ஒரு கிளாஸ் எடுத்துடலாம்னு பார்த்தேன்.
எனர்ஜி எஃபிஷியன்சி பாலசுப்ரமணியன் சார் கேட்கறேன்னு இல்லைங்க சார்?
எந்த பாலசுப்ரமணியம்?
நம்ம
இவரா? டடா.
ஆஹா
இவரா?
டெடா இல்ல, இவருதான். நம்ம
கோல். எஸ் எஸ்.
ஆமா, கோல்.
எஸ் எஸ் எஸ்.
அவர்கிட்ட கேட்டுட்டானா நாளைக்கு அதை கன்ஃபர்மேஷன் பண்ணிட்டானா குயிக்கா ரன் த்ரூ பண்ணிக்கலாம் சார். எனக்கு
நாளைக்கு கால் கண்டிப்பா கேட்டுறேன்.
எனக்கு இன்னொரு இதுல இருந்து யாரோ ஒருத்தவங்க போன் அடிச்சாங்க சார். இசிபிசி கோட் அப்ளை பண்ணிட்டு எனர்ஜி ஆடிட்டிங் பண்ணி தர முடியுமா அப்படின்னு ஒருத்தவங்க கேட்டாங்க. நம்ம அந்த மேடம் இருந்தாங்க இல்லைங்களா,
ஆமா,
அவங்க நம்பர் கொடுத்து அவங்கள்ட்ட பேச சொல்லலாமா?
கொடுக்கலாம்.
அதுக்கு அவர் என்ன கேட்டாருன்னா, கிரீன் பில்டிங் நான் மாத்திட்டா எனக்கு வந்து சப்சிடி கிடைக்குமா அப்படின்னு கேட்டாரு.
அதெல்லாம் அவங்கதான் சொல்லுவாங்க. கரெக்டா?
அதுதான். அதனால எனக்கு அது ஏன்னா நோடல் ஏஜென்சி வந்து டேஞ்சர்கோ தான் ஆக்சுவலா. பட் இங்க இருக்கவங்களுக்கு என்ன சொல்றதுன்னு தெரியல. சரி, அதனால நான் உங்களுக்கு எதுவும் சொல்லிக்கல. அதான் இன்னைக்கு கேட்டாங்க திடீர்னுட்டு. நம்ம குரூப்ல இருந்து வெளியில போகுது போல இருக்கு செய்தி. எப்படியோ நம்பர் எடுத்து எதுலயோ பேசி, சார் எனர்ஜி ரிலேட்டட்ல எனக்கு கொஞ்சம் டவுட் வருது அப்படின்னு சொல்லி அவர் கேட்டாரு திடீர்னு ஒருத்தர். அதுக்காக தான் இதையும் கேட்டு போனோம்.
அகத்தியம் கொடி கட்டி பறக்குது போல இருக்கு.
அகத்தியத்துல இருந்து இல்லைங்க சார், அகத்தியத்துல இருந்து இல்ல, ஜெனரலா எனர்ஜி ரிலேட்டட் இது.
சரி. இல்ல அவங்க எப்படி புடிச்சிருப்பாங்க? அகத்தியம் வழியாதானே வந்திருப்பாங்கன்னு.
அதுல எனர்ஜி ரிலேட்டட் அப்படின்னு கேட்டிருக்காங்க. ஆனா இசிபிசி நம்ம இதுதானே மேடம் தானே வந்து பேசினாங்க.
ஆமா, அவங்க
அதான்
ரைட் பர்சன் அதுக்கு.
அதுக்குதான் சரி அவங்களே கொடுத்து எனக்கு பேச சொன்னாங்களா அல்லது இசிபிசி வேற யாராவது சொல்லி பேசிருக்காங்களான்னு எனக்கு தெரியல. சரி அதனால கேட்டுக்கலாம் அப்படின்னு. சரி
எனக்கு ஒரு
பாக்கலாம்.
2 இயர்ஸ் முன்னாடி என்ன பண்ணேன், என்னோட ஒரு குரூப் என்ன பண்ணாங்க, ஒரு குரூப் ஆஃப் ஃப்ரெண்ட்ஸ் வந்து அவங்க புதுசா அந்த எனர்ஜி ஆடிட்டிங் ஆரம்பிக்க போறேன் அப்படின்னு
சரி.
சொல்லிட்டு ஒரு கிளையண்ட்டையும் பிடிச்சி என்ன
ஆ,
பண்ணிட்டாங்க, ஒரு பெரிய பர்பஸ் வந்து எனக்கு ஹெல்ப் பண்ண சொன்னாங்க. உட்காந்துட்டு இந்த ஏடிஎம்ல வந்து எப்படி எல்லாம் கன்வெர்ட் பண்ணலாம்னு சொல்லிட்டு கிட்டத்தட்ட ஒரு 48 ஏடிஎம் என்னோ எல்லாத்தோட டிசைன் டேட்டா கொண்டு வந்து கொடுத்தாங்க. கிட்டத்தட்ட ஒரு 10 நாள் ஒர்க் பண்ணி கொடுத்தேன். கடைசியில பாத்தீங்கன்னா அவன் டேட்டா வாங்கிட்டு எஸ்கேப் ஆயிட்டாங்க போல இருக்கு. அவன் வந்து போயிட்டாங்க.
முக்காசி பேர் அப்படிதான்.
அதுக்கப்புறம் போன் கூட தான் எடுக்கல. என்ன டிசைன் என்ன பண்ணணும் எல்லாத்தையும் போட்டு, அதான்
ஆ,
இவங்களுக்கு பிசினஸ் பண்ண தெரியல போல இருக்கு அந்த மக்களுக்கு. அதனால
ஓகே.
அதுதான்
அதுதான்.
டெக்னிக்கலா பண்ணலாம்னு பார்த்தாங்க. எனக்கு
ஆ,
ரொம்ப ஆர்வத்தோட சரி நம்மகிட்ட முதல்ல ஒரு எனர்ஜி ஆடிட் வருதுன்னு சொல்லிட்டு பண்ணி கொடுத்தேன் அவங்களுக்கு. நான் என்கிட்ட
ம்,
எனக்கு காசுலாம் வேணாம், நான் பிசினஸ் கிடையாது, எனக்கு நீங்க சொல்லுங்க நான் டெக்னிக்கலா பண்ணி தரேன்னு பண்ணி கொடுத்தேன். கடைசியில பார்த்தா இந்த மாதிரி ஆயிடுச்சு, அவங்களுக்கு பாவம் ஆயிடுச்சு.
அதுதான். எனக்கு
சரி, சரி.
இன்னொரு டவுட்
அப்புறம்
சார்.
முத்துக்கனி இருக்கீங்களா?
Yes, sir.
சொல்லுங்க சொல்லுங்க போலாம்.
இல்லைங்க சார், எனக்கு ஒரு சோலார் செல்லு தனியா கிடைக்குமா சார்? சோலார் செல்லுங்கள் ஒரு சோலார் செல் தனியா, அதாவது இப்ப பேனலா இல்லாம யூனிசெல் யூனிசெல் வந்து நிறைய கிடைக்குமா அப்படின்ட்டு. 1 2 இல்ல, கொஞ்சம்
ஸ்ட்ரிப்
நிறைய.
மாதிரி ஸ்ட்ரிப் மாதிரி
ஆ,
நிறைய குவான்டிட்டில.
நிறைய குவாண்டம்ல கிடைக்குமான்னு, அத கோயம்புத்தூர்ல எங்கேயாவது கிடைக்குமா அப்படின்னு கேட்கறதுக்கு சோர்ஸ் இருக்குமா சார்?
தெரியலையே, நான் இதுலதான்
நம்ம கடை நான் அவளை கேட்டு பாக்குறேன் சார்.
கேட்டு சொல்லுங்களேன் சார். சரிங்க சார். கிரிதே சார், நீங்க கேட்டுட்டு சொல்லுங்களேன்.
சொல்றேன் சார். செல் மட்டுமா?
யூனிசெல்லா வேணும். நான்
யூனிசெல்
அதாவது ஒருத்தர் வந்து என்னன்னா இந்த ஆட்டோ க்ளோஷர் பண்ற மாதிரி, இந்த சன்ஃபிளவர் ஓப்பனிங் க்ளோசிங் மாதிரி ஒரு ஐடிஐ படிச்ச ஒருத்தர் வந்து செய்யணும் அப்படின்னு சொல்லிட்டு ஆர்வமா வந்தாரு.
ஓகே
அவர் டிசைன் எல்லாம் பண்ணிருக்காரு, மெக்கானிக்கல் டிசைன் எல்லாம் முடிச்சிட்டாரு அவரு.
ஓகே
ஹி வாண்ட் டு செட் இட் அப். நான் இந்தியாவுக்கு ஏதாவது செய்யணும் அப்படின்னு சொல்லிட்டு அவர் ஆர்வமா வந்தாரு.
ஓகே
பட் நம்ம அவரை டிஸ்கரேஜ் பண்ண முடியல. அதெல்லாம் இங்க இந்தியாலயே ப்ரொடக்ஷனே கிடையாது, மேக் இன் இந்தியா ஸ்டிக்கர் மட்டும் தான் பண்றாங்க. நான்
ஆமா
எங்க இருந்து போய் கண்டுபிடிக்கிறது? சைனா வேணா போய் நீங்களே வாங்கிட்டு வந்துருங்க அப்படின்னு சொன்னேன் நானு. பட் இருந்தாலும் கோயம்புத்தூர்ல எங்கேயாவது கிடைச்சி நம்ம சர்க்கிள் ஏதாவது கிடைச்சிச்சுன்னா பாவம் அந்த ஒரு குறிப்போட இருக்கக்கூடிய ஆட்களுக்கு ஏதாவது செய்யலாமே அப்படின்றதுதான் பார்த்தேன்.
கேக்குறேன் சார், அவளை கேக்குறேன். எனக்கு இருக்க கான்டாக்ட்ஸ்ல கேக்குறேன்.
கேட்டாயமா சார்?
கேட்டு சொல்றேன், நாளைக்கே சொல்றேன்.
ஓகேங்க சார். இப்போ கவுண்டவுன் வந்து எத்தனை நாள் சார் இருக்கு எக்ஸாமுக்கு?
நிறைய டைம். நான் திருப்பதிக்கு போகும்போது கிட்டத்தட்ட அப்படியே விட்டுருச்சு போல இருக்கு. நான் மெக்கானிக்கல் என்ன கவர் ஆயிருக்குன்னு பார்த்தேன்.
கவர் மட்டும்தான் ஆயிருக்கு, கவர் இப்போ எதுவுமே ஆகல.
எனக்கு எலக்ட்ரிக்கலையாவது ஓரளவுக்கு நான் கொஞ்சமாவது ஒரு அட்லீஸ்ட் ஒரு 30 to 40% கவர் பண்ணிட்டா ஒரு ஃபீல் இருக்கு. பட் மெக்கானிக்கல்ல எவ்வளவு போறீங்கன்னு தெரியல எனக்கு.
மெக்கானிக்கல்ல மேடம் வந்து எடுத்திருக்காங்க சார், அவ்வளவுதான். மெக்கானிக்கல்ல நம்ம கிட்ட இருந்தவங்க எல்லாருமே ஏமாத்துறாங்க. 147 பேர் இருக்காங்க மொத்தம். ஆனந்த் வந்து வாய்ப்பே கிடையாது.
முக்கியமா நம்ம ஆனந்த் குமார்
கடைசி வரைக்கும் சொல்லுவாரு ஏதாவது ஒரு காரணம்.
கிளாஸ் போறதே விட்டார் போல, நீ கூப்பிடுறீங்கன்ட்டு.
இல்ல, யூடியூப் லைவ்ல தான் இருக்கு, பாத்துட்டாவது வரட்டும்.
சரி சரி.
இல்ல, கவுண்ட் டவுன் மாதிரி ஒண்ணு போட்டுட்டு எக்ஸாமினேஷன் பாயிண்ட் ஆஃப் வியூல வந்து கொஞ்சம் டிஸ்கஷனு. நான் வேணா தர்மலிங்கம் சார் வேணா ஒரு நாள் கூப்பிடுறேன்.